Hey, welcome guys. So in this video, let's talk about Pythagorean quadruple. Okay, so before I start, hope you guys subscribe to my channel. And my channel is basically about math and physics and lots of interesting topics if you want to see. Yeah, so don't waste our. Okay, so let's quickly see. So the famous results, I guess everyone already knows. If you don't know, I will provide another video. I will post my previous video below. So the results is called a Pythagorean triple. Means that the solution basically is a solution for a squared plus b squared equals c squared. Okay, so you want all of them to be integer. Okay, so the famous result like 3, 4, 5, right, and 5, 12, 13, and yeah, I mean there I think 8, 15, 17, and then there are a lot. Okay, so the theorem basically, which is very old, I guess maybe 2000s, already 2000s years, is that there are infinite solutions. Okay, and which is really amazing that if you let a to be x squared minus y squared, b to be 2xy, and easy to check that c is x squared plus y squared. So you can easily prove this by just do basically you can easily prove this by doing your elementary school algebra. You just square it and then you get square it, you get square. Okay, so easy to prove. Okay, so you can pick, if you pick xy to be an integer, then definitely you will create infinite triples. Okay, and this can be viewed as if you learn about the algebraic geometry. So let me provide a modern view. So a modern view is that you consider a circle. Let's say this is x and y. So you get x squared plus y squared equals to 1. So you consider a circle. And here, at this point is called 1, 0. Right? And then you create any line, which is slope is called t. Okay, so the key idea is that so fact is that if t is rational, then you can easily show that if t is rational, right, that means you have a line in a circle. So so intuitively, if t is rational, then the intersection, should be rational. So basically, you can produce any, you can create any, and also any rational points on this circle, except for the 1, 0, can be produced by t, because you connected it. You connect two rational points, then the slope will be rational. Okay, so let's easily quickly prove this. Okay, so yeah, so let's see. So idea is that from here that you know that you can parameterize y to be t x minus 1. Right, and then you plug x squared plus y squared equals to 1, and you get t squared x minus 1 squared x squared equals to 1. Okay, and then you can easily show that one can choose x to be, you can solve this, right? And yeah, you can easily solve this from quadratic equation for x, and I guess you will get this t squared minus 1 t squared plus 1. Then you can improve your y to be this. Okay, and since our original equation is this, right? So I can flip x and y. I can flip x to be minus x. So the conventional parameterization is this. And then okay, then you get this. And finally, so but that means that the parameterization, you can easily show this, right? You can easily show this is 1. Right, so for any rational number, we'll give you this, right? And then you can easily just times it, you get the proof. At least, so it's t squared, 1 plus t squared squared, and then just let t to be a divided by b. Okay, so if t is a divided by b, you get b squared minus a squared plus 2ab squared equals a squared plus b squared squared. Okay, so from here to here. Yeah, so this is a theorem that and how the derivation and how can people prove that there are Pythagorean triple. Oh, but Pythagorean triple is not our goal, right? Our goal is called the Pythagorean quadruple. Okay, so let's talk about the Pythagorean quadruple. Okay. So the goal is to find solutions like a squared plus b squared plus c squared equals d squared. Yeah, I mean you guys can play around with like an exercise to find a solution by yourself, and we hope that the a, b, c, d will both be integer or positive integer. Okay. Yeah, this is not very obviously that there are infinite solutions, right? So how many solutions is this is also a question. Oh, so still want to say that there are infinite solutions. I mean, it's very hard to find a solution. If I remember correctly, maybe 3 squared plus 4 squared plus 5 squared. Let's see. So it's 9 plus 16, 14 plus 25. Yeah, this is not. Yeah, I mean, you guys can try for. Let's see. So I just want to find a solution. Yeah, I want to find a solution like 6. Yeah, okay. So let's see. 2 square. Let's see. Let's provide example. So example is that 2 square plus 4 square plus 4 square, right? It's 4 times so 4 plus 16 plus 16 should be 36, right? So 32 plus 4, so it's 36. So it should be 6 square. So you can divide it. Yeah. So this is one solution. Yeah, so this is the example. So our goal is to show that there are infinite. So show that infinitely. Okay. Yeah. So the key idea is to find a good parameterization. Right. So find a good parameterization. And then this is very difficult in the modern mathematics. Is that where you give an algebraic curve, there's a parameterization. Okay, so but my idea is okay. So let's say idea one. So idea one, I would guess that since I already right. So if somebody give you, okay, somebody give you, then I would guess that from a Pythagorean, I would say that maybe I can choose d to be. Let's see. I would think that hopefully I can choose d to be that's a p squared plus m squared plus n squared. Why? Because I copied from the Pythagorean triple, right? So I can guess. I would guess d can be written as a sum of 3 squared, and I should pick one to be this one, right? P squared minus m squared minus n squared. So let's see. If I do this, then d squared minus a squared will give us will give me that 2p squared and 2m squared plus 2n squared. And then I hope this to be b squared plus c squared. Okay, so that means I can choose b to be 2pm, c should be 2pn. Okay, so now this finished the proof. Okay, so that means we have the one parameterization. So one parameterization, which is a is this, and the b can be choose this, c can be choose this, d can be choose p squared plus m squared plus n squared. Okay, so easy to see. Okay, so there are infinite solutions, and you can parameterize. Okay, but this solution give me some confusion, right? The confusion is that there are 4 variables here. I think that I only have the 3 degree of freedom, right? 3 DOF. And this is possible that this is possible, right? The reason is that we have 4 solutions. Right, but it seems like that since we have this constraint, right? We have a squared plus b squared plus c squared equals d squared, which is complicated, and so we should have 3 degree of freedom, right? But this is not the case. Okay, so let's see the more general parameterization. So one parameterization is that you can that d to be m squared plus n squared plus b squared plus q squared, and you just let a to be m squared plus n squared minus p squared minus q squared. Okay, now let's go to proof. Let's see this, right? So this will give us that 2m squared plus 2n squared, and also 2p squared plus 2q squared, and I will hope to be p squared plus c squared. Okay. Okay, so this is the funny exercise. This is funny exercise to prove that yeah. So there is a result, the famous identity. I said let's say x1 x plus x1 squared plus y1 squared times x plus times x2 squared plus y2 squared can be written as x1 x2 plus y1 y2 squared plus x1 y2 minus y1 x2. Okay, so simple exercise. Okay, so from use this identity, one can choose. Let's see. So I guess one can choose b to be 2 times mq plus np square plus 2 times mp minus nq square. Right? So yeah, just use this identity and take out these two. Okay. So from here, that you can see that this is the more general parameterization. Yeah, so hope you guys like this video. So from here, this video, we know that there are infinite quadruple, and we have the parameterization. And there's a deep theorem says that actually the converse is true. So basically every solution. So basically you take any solution of the quadruple, then you can always find the MNPQ such that it can be parameterized as this. Okay, so this is the converse result, which is much powerful than just the existence result. Okay, hope you guys like this video and subscribe to my channel. Thanks.